to Mr. Leek's free science tutorials. Now, in this video, there isn't a question, right? This is going to be a lot to do with actually learning symbols, right? It's all to do with the electrical symbols. You need to know the symbols to be able to then answer GCSE questions and be able to draw circuits. So what I'm going to do is I'm literally going to go through all the most common symbols, right? Say what they are and basically what their role is. The first one here is a cell, right? So a cell, right, is a store of chemical energy, right? And what it is, it's just one individual source of current voltage. A battery is two or more cells in series. In series means in a line, and you can see there's two there, and the number of dots in the middle, right, basically says that there's two or more. A switch can be called an open or closed switch. That's an open switch. Put the little line down there so it goes across as a closed switch. And what that does, it breaks the circuit, turning the current off. Okay, now obviously you've got switches all the way around your house, your light switch. All you got to do is turn it on, turn it off, and then the switch breaks the circuit, turning the current off. That there is a lamp, sometimes called a filament lamp. It's when current flows, right? So when current flows through that, it lights up. An ammeter measures the current. So an ammeter measures the amount of current that actually flows through it. We'll talk about it in a later video, but basically an ammeter has to be put in series in a circuit. That means it has to be within the actual line. A voltmeter measures the potential difference, right? This is a big confusing thing, right? Is voltage and potential difference is the same thing, all right? So if ever you see voltage, right, it means potential difference. If you ever see potential difference, it means voltage. A voltmeter has to be put in parallel. So therefore it isn't in the main circuit as it actually goes around. Other symbols, we've got a diode. This is then a diode, right? And that is, it allows current to flow only one way. LED, light emitting diode. Absolutely brilliant these days. You can get little LEDs, right? They'll put out huge amounts of light. And what you can do is you can see the little symbol in the middle is a diode, the D. The little arrow sticking out is light emitting. Light emitting means emitting, giving out. And what that does, it emits light when current flows. These are used now on Christmas lights and all those kind of things because they're take very little current, right? They're very, very low watts. You know, to get a 1 watt light bulb now, right, can give out a huge amount of light. An LDR is a light dependent resistor. The little rectangle in the middle is a resistor. The arrows apply to light, and the arrows in means dependent. Resistance low in bright light. A good example of that is street lamps, right? Where when the light gets down to a certain level, what happens is the street lamps turn on. And there's an LDR that's involved in that, a light dependent resistor. A fuse. Now, a fuse stops current flowing. So it melts when current is too high. So the way I always used to draw it was that left-hand side there and that right-hand side there, I always used to do it as a big fat wire. In the middle, I used to do it as a little thin wire. So when electricity passes down the big fat wire, right, and it gets to the little thin wire, if there's too much electricity, the little thin wire breaks. Right, now what that does is that then stops, right, the electricity continuing around the current, around the circuit. I was using a saw in my back garden a year or two ago, and it stopped working. And I thought, oh my God, I'm going to have to go and buy a new saw, right? But then what I did is I changed the fuse, which cost me about 10p, and then the actual saw then started to work again. So always check the fuse, and the fuse, it's a bit like a safety device. A resistor slows down the flow of the current, right? So it affects the size of the current flowing. Think about a hose pipe, right? If you've got a hose pipe and you've got water flowing through it, and then you squeeze it, the water slows down. That's the role of a resistor. A variable resistor, basically what it means, that arrow there, is you can move it backwards and forwards, and it allows the current to be varied. A thermistor, now there's an obvious word in there, therm, temperature, is a resistor low, or resistance is low at high temperatures. A good example of those is in a greenhouse. And what will happen is, if you've got a thermistor that's set in place with the appropriate circuit, if it gets too hot, the window's open. If it gets too cold, a heater comes on. And what it does then, it keeps the actual greenhouse at exactly the right temperatures. So, a cell, a battery, a switch, a lamp, an ammeter, a voltmeter, a diode, an LED, an LDR, a fuse, a resistor, a variable resistor, and a thermistor. Thank you.